Hey everyone, welcome back to the channel. Have you ever looked up at the night sky, seen those countless stars, and wondered if we'll ever actually get there? I mean, not just to Mars or Jupiter, but truly out there, beyond our own solar system, to explore other stars and maybe even find new Earths. It sounds like pure science fiction, right? Like something straight out of Star Trek or Interstellar. But is it? Will humanity ever truly leave our cosmic backyard and venture into the great unknown of interstellar space? Today, we're going to dive deep into this question. We'll look at the mind-boggling challenges, the incredible technologies being developed, and the fundamental reasons why this epic journey might be humanity's ultimate destiny. So, buckle up, because we're about to go on a trip to the stars. First, let's get a sense of the scale we're dealing with, because space is, to put it mildly, big. Unimaginably big. Our solar system itself is huge. The Voyager 1 probe, one of the fastest objects we've ever launched, has been traveling for over 45 years and has only just crossed into what we call interstellar space, the area between stars. The nearest star to us, Proxima Centauri, is about 4.2 light-years away. A light-year is the distance light travels in a year, which is about 9.5 trillion kilometers. So, Proxima Centauri is roughly 40 trillion kilometers away. If Voyager 1 were headed in that direction, which it isn't, it would take it about 75,000 years to get there. 75,000 years, that's longer than all of recorded human history. So, the first and most massive hurdle is distance. Conventional rockets, even the most powerful ones we can dream up today, are simply too slow. We need a completely new way to travel. So, what are the options? This is where things get really exciting and sound like they're straight out of a sci-fi movie. One of the most promising concepts is the solar sail. Instead of using rocket fuel, a solar sail would be a huge, ultra-thin reflective sheet, maybe kilometers wide but thinner than a piece of paper. It would be pushed by the pressure of sunlight itself. Photons, particles of light, have no mass, but they have momentum. Over time, the constant push from these photons from our sun could accelerate a small probe to incredible speeds. And to go even faster, we could use powerful lasers based on Earth or in orbit to give the sail an extra massive push. This is the idea behind the Breakthrough Starshot initiative, a real project backed by scientists like the late Stephen Hawking. Their goal is to send a fleet of tiny nanocrafts to Proxima Centauri, accelerated by a giant laser array to about 20% the speed of light. Another concept is nuclear propulsion. We're not talking about nuclear bombs, but controlled nuclear reactions. One idea is nuclear thermal propulsion, where a nuclear reactor heats a propellant like hydrogen to extreme temperatures and expels it out of a nozzle, creating thrust. This is much more efficient than chemical rockets. A more radical idea was Project Orion, conceived back in the 1950s. The plan was to detonate a series of small nuclear bombs behind a massive spaceship. A giant pusher plate at the back of the ship would absorb the shock of each blast and propel the craft forward. It's a bit explosive, and there are obvious safety and treaty concerns, but the physics is sound. It could theoretically get a large, crude ship to a nearby star in about a century. A more modern and safer version is nuclear pulse propulsion, using controlled fusion reactions. If we can ever master nuclear fusion, the same process that powers the sun, we could create engines that are vastly more powerful and efficient than anything we have today. And then there's the really out there stuff, the things that bend the rules of physics as we know them. I'm talking about warp drives. The idea, popularized by Star Trek, isn't just fiction. It's based on a real theoretical concept called the Alcubierre drive. The idea is that you wouldn't travel asterisk through asterisk space, but rather you'd warp space-time asterisk around asterisk your ship. The drive would compress space in front of the ship and expand it behind, creating a sort of wave that the ship could ride. Inside this warp bubble, the ship itself would be stationary, so the crew wouldn't be crushed by extreme acceleration. You could effectively travel faster than the speed of light without breaking the laws of physics locally. The major catch: it would require a hypothetical form of matter with negative mass, something we've never observed and don't know how to create. It's a massive, perhaps impossible, hurdle. But it shows that physicists are thinking about these crazy ideas. Let's say we solve the propulsion problem. We build our incredible starship and we're ready to go. What other challenges do we face? Well, the journey itself is incredibly perilous. Interstellar space isn't completely empty. It's filled with dust and tiny particles. Hitting a grain of sand at 20% the speed of light would be catastrophic. It would have the kinetic energy of a massive explosion, capable of vaporizing any ship we could build today. So, any interstellar vessel would need incredibly advanced shielding, perhaps using powerful magnetic fields to deflect charged particles. There's also the problem of cosmic radiation. Outside the protective magnetic bubble of our sun, the heliosphere travelers would be exposed to a constant barrage of high-energy cosmic rays. Over a long journey, this radiation would be lethal to humans and could fry electronics. The ship would need heavy shielding, which adds a lot of mass, which in turn makes it harder to accelerate. It's a difficult balancing act. And this brings us to the human element. If a journey takes decades or even centuries, what does that mean for the crew? This is where the concept of a generation ship comes in. This would be a massive, self-sustaining world in a can, a closed ecosystem that could support a community of thousands of people for generations. They would be born on the ship, live their entire lives on it, and their descendants would be the ones to finally arrive at the destination. The psychological and sociological challenges are immense. How do you maintain social order, knowledge, and a sense of purpose over centuries in a tiny, isolated environment? It's a question that has fascinated science fiction writers for years. Another possibility is suspended animation or hibernation. If we could safely put humans into a state of long-term sleep, it would solve many of these problems. The crew could sleep through the long journey and be woken up upon arrival. We're making progress in understanding hibernation in animals, but applying it safely to humans for decades is a whole other level of complexity. And, of course, we need a destination. Where would we even go? Using powerful telescopes like the James Webb Space Telescope, we're discovering thousands of exoplanets orbiting other stars. Some of these are in the habitable zone, the region around a star where conditions might be right for liquid water to exist on a planet's surface. The TRAPPIST-1 system, for example, is about 40 light-years away and has several Earth-sized planets in its habitable zone. But just because a planet is in the right zone doesn't mean it's habitable. It could have a toxic atmosphere, extreme temperatures, or be blasted by radiation from its star. Before we send anyone, we need to send robotic probes first to scout these worlds in detail, to analyze their atmospheres and surfaces, to make sure we're not sending people on a one-way trip to a dead rock. So, with all these monumental challenges, why would we even bother? What's the point of pouring unimaginable resources into a project that might not pay off for centuries? There are a few big reasons. The first is survival. As Stephen Hawking often said, to ensure the long-term survival of the human species, we must eventually become a multiplanetary and then a multistellar species. An asteroid impact, a supervolcano, a man-made catastrophe. There are many things that could threaten our existence here on Earth. Having a foothold in another star system would be the ultimate insurance policy. The second reason is pure, unadulterated curiosity. It's in our DNA. We are explorers. From the first humans who walked out of Africa, to the sailors who crossed the oceans, to the astronauts who walked on the moon. We have always been driven to see what's over the next hill, beyond the next horizon. The stars are our final frontier. The drive to know, to discover, to understand our place in the universe is a powerful motivator. And finally, the pursuit of such a grand goal would drive technological innovation in ways we can't even imagine. The challenges of interstellar travel would force us to make breakthroughs in energy, materials, science, artificial intelligence, medicine, and biology. Just like the Apollo program gave us everything from GPS to medical imaging, the quest to reach the stars could revolutionize life here on Earth. It would unite humanity in a common purpose, a shared dream that transcends borders and politics. So, will we ever leave our solar system? I think the answer is yes. It won't be easy. It won't be soon. It will likely be the most difficult and ambitious undertaking in human history. The people listening to this video probably won't see it happen. Maybe our children's children won't either. But the first steps are being taken right now. The theoretical work is being done. The early stage projects are being funded. We are laying the foundation. Humanity is a young species, and we are just beginning our journey. We've gone from horse-drawn carts to landing on the moon in less than a century. Who knows what we can achieve in 1,000 years? Or 10,000? The journey to the stars is a long one, but it's a journey that I believe humanity is destined to make. It is our legacy, written in the stars. What do you think? Is interstellar travel an inevitable part of our future, or is it a sci-fi fantasy? Let me know your thoughts down in the comments. I'd love to hear what you have to say. Thanks so much for watching. If you enjoyed this journey through space and time, do you want to forget to hit that like button and subscribe for more deep dives into science and the future? Until next time, keep looking up.